Hi everyone. On this episode of Talk the Thought Process, we're going to learn how to work with units. So in chemistry, as in many other sciences, and even in the kitchen, we have to do things like convert values from one set of units to another. And as long as we're thinking about the thought process and talking it through as we do this, we can assure ourselves that we won't make any mistakes in doing so. So here is an example problem of converting units. There are 12 eggs in a dozen. How many eggs are in 2 dozen? If you have 18 eggs, how many dozen do you have? So I'd like you to think about whether or not this is an easy problem or a hard problem. It might seem kind of easy to you because you've worked with eggs before, and you can picture what a dozen is. Now consider this problem. There are 4.184 joules in a calorie. How many joules are in 5.6 calories? If you have 425 joules, how many calories do you have? So do you think this is an easy problem or a hard problem? Well, you can't visualize joules and calories in the same way that you might be able to visualize eggs and dozens. However, the problem is really the same as the first problem. So learning the process and thinking through the process will help you to do a problem like this, even though you may not be familiar with joules and calories, and get the correct answer. The process we use is called dimensional analysis, and it works by the same process no matter if you're dealing with eggs or you're dealing with joules and calories or any other kind of units, different units to represent the same things. Okay, all of these problems involve using what's called a conversion factor, and a conversion factor is where you have equivalent amounts of things, like you might have 12, where did my pen go? Here we go. 12 eggs equals 1 dozen. Right, that's a conversion factor that you would use to solve this problem. And you might be able to look at this problem and say, hey, professor, I don't need to use any kind of process. I know that in 2 dozen there are going to be 24 eggs because this is an easy problem. But what you want to do is follow a process. So please stay with me and follow the process even when it seems easy. So you start with the gathering the conversion factors, and the conversion factors tell you what's equivalent. So for example, in this problem, as I just wrote before, 12 eggs is equal to 1 dozen. That's our conversion factor, right? Which shows us that we can have equivalent things, amounts of things expressed in different units. When we do the problem, we start with what we have, we convert it to what we want, we pay attention to the units while we're doing that, and then we'll have finished the problem. So we'll demonstrate how this process works, and we'll be talking through the thought process. So there are 12 eggs in a dozen. How many eggs are in 2 dozen? And I know what you're thinking is, I know there's 24 eggs. Look, I can prove it right there. They are. And we can count them. 2, 4, 6, 8, 10, 12. 14, 16, 18, 20, 22, 24. And that's great that you can visualize that and do this problem in your head. But what we want to do is work with the process when we have something that's easy that we can visualize to make sure we understand how the process works. So again, we start by writing down the conversion factors. 12 eggs equals 1 dozen. And then we start with what we're given. So we're asked the question, how many eggs are in 2 dozen? So you think we're given 2 dozen eggs, or we're asked about 2 dozen eggs. So that goes on the left side in our problem. It's what we're given in the problem. And then we want to convert that to what we want. And so we have to look for the question, how many eggs are in a dozen? And so that's going to go on the right side after our equal sign. We want to convert dozen into eggs. So we do that by multiplying what we're given by the conversion factor. Okay, and this is our conversion factor. We're going to put the 1 dozen on the bottom, and we're going to put the 12 eggs on the top. And the reason that we do that is because we want to get the number of eggs. So the dozens will cancel, and the eggs will be left as a unit, right? Because when we multiply through by numbers that have numerator and denominator, the numerators and denominators are the same, will cancel, right? So the dozens will cancel, we're left with eggs, and we get 24 eggs. Okay, so great example of how to use the process. And again, even though we can do this one in our heads without a process, it's good to practice that process. So likewise, if we have 18 eggs, how many dozen do you have? So in this case, we're given the quantity of 18 eggs. So that goes on the left. We're asked how many dozen that is. So that's going to be the units of our answer, right? Dozen is what we want. Eggs is what we're given. We multiply what we're given by the conversion factor. We have the same conversion factor that we've already used. 12 eggs equals 1 dozen. However, in this case, we're going to put the 12 eggs on the bottom and the 1 dozen on the top. And we know that's correct because the eggs are going to cancel and we'll be left with the dozen, which is what we want. And so when we multiply 18 times 1 over 12, we're going to get 9/6, which is 3 halves, which looks like 1.5 dozen. Okay, so this one was the easy problem because you can visualize it, right? You can look here at 18 eggs and see that it's 1.5 dozen. And we practice that so that we can understand the process. So now let's do it for this problem here with joules and a calorie. So calories are units of energy, joules are units of energy. We see calories a lot in everyday life, like if we're looking at a candy bar we want to eat and seeing how many calories in it, so we know how much we have to run later to burn up the calories we've eaten. That would be interesting to know about the calories. But in science, we often use the joule instead of the calorie. Okay, so we're given the conversion factor here, 4.84 joules is equal to 1 calorie, and we're asked how many joules are in 5.6 calories. So thinking and talking through the process, we first write the conversion factor, 4.184 joules, we use a capital J for that, equals 1 calorie. And we'll just abbreviate that CAL. Okay, so again, what are we given? How many joules are in 5.6 calories? Right, so the 5.6 calories is what we're given in the problem. So we put that on the left. And then what we want in the problem is what they're asking us for. How many joules? Right, that's the question we're being asked. So that's going to go on the right, joules. We multiply by the conversion factor in order to convert it. And so here's our conversion factor. The 1 calorie goes on the bottom. The joules go on the top, 4.184 joules. We make sure we set that up right by canceling out the calories and being left with joules. And then we grab our calculator and we do the math here. So we've got, let's see, 5.6 times 4.184, and we get 23 joules. Okay, now my calculator is telling me that it's 23.4 joules, but in science we want to use the correct number of significant figures, and there's 2 here in this number. There's 4 here in this number, and whenever we multiply two quantities, the answer should be expressed to the number of significant figures that is the least amount for the things you multiply. So we have to go with 2 significant figures, 23 joules. All right then, so now we can do this problem here. If you have 425 joules, how many calories do you have? So we're given 425 joules. We put that down on the left. And we want to convert that to calories. How many calories do you have? So that's going to be the units of our answer. We multiply by the conversion factor, okay? And so here's the conversion factor, the same one we used up here. What are we going to do? We're going to put the joules on the bottom this time because we want those to cancel out. And we're going to put the calories on the top, 1 calorie. We check our units to make sure the right units cancel and we're left with the ones that we want. And then we do our math. 425 divided by 4.184 equals 102. Okay, so again, I'm rounding off to 3 significant figures in this case because there's 3 in this one over here. Answer 102 calories. All right, so when you do these problems, you do want to think about the answer and make sure it makes sense, right? Because the most common error that a student will make is inverting these conversion factors and putting the wrong thing on the top and the bottom. So there's 2 ways you can check that. You can check that by crossing out the units and making sure you get the right ones. You can also check that by looking at the answer and making sure it makes sense. Okay, so if 1 calorie is a little more than 4 joules and you have almost 6 calories, you're going to have about 24 joules, right? So that answer is pretty close. That makes sense. If you have 425 joules, that's a lot more than 1 calorie, right? So you should get an answer 102. And so you can check the answer in terms of if it makes sense by thinking about what you're doing, again, and making that part of your thought process, making sure the answer makes sense, and also making sure that you've answered the question that was asked. Okay, so that's the process for talking it through. Gather the conversion factors. That's which quantities are equivalent. Start with what you have, write that on the left. Convert it to what you want, write that on the right after the equal sign with the correct units, and then use your conversion factor to get the correct units. Pay attention to those units to make sure you get the correct answer. Okay, so here's something for you to practice on your own. And again, try to do this step by step rather than just jumping to the answer to make sure you understand the process. Because in chemistry, we will be doing lots of conversions that will involve multiple steps of converting one thing into another. So it's good to make sure that you understand the most simple basics. So how about this one? How many quarters would you need to pay for something that is $15.75? That's something you can visualize and work with. But now try it with something that is harder to visualize. A mole of an ideal gas occupied 22.4 liters. Question, how many moles are in 6.2 liters? This is something that students tend to have problems visualizing in chemistry. A mole is a quantity of some chemical species. A mole of an ideal gas happens to occupy or fill 22.4 liters, right? And so this is the conversion factor. We can calculate how many moles are in 6.2 liters. So practice those on your own, and I've provided for you here the answer, 63 quarters. Now, I just want to check you, make sure that rather than just doing it in your head, which maybe many of you can do, each dollar is 4 quarters, 15 times 4 is 60, plus 3 more is 1575, that's 63. Instead of doing that, right, just write it out to make sure you've got the process correct. And then finally, do the same with the moles of the ideal gas. You should have 0.28 moles. And again, it makes sense, right? This is about 1/3. And if you have 22.4 liters, this is a little more than, a little less than 1/3 of your quantity that you have. So you always want to talk through the process in that way. Talk through the process. This is how we work with units and doing unit conversions. Remember, talk through the process. That will help you to ingrain it in your thinking and to use it correctly when you need to use it.